engineering spokesperson joins us from the value engineering team at Catchpoint, working with some of the biggest companies in the world on the digital services. Now, when we talk about the evolution of networks over the last decade or so, from traditional WANs and VPNs to SD-WANs, just to make the user experience better and faster, the question is that really the case? Are the networks still observable? To answer those pertinent questions for all of you, let's welcome onto the stage Mr. Wasil Banday. Wasil, we are all waiting to hear from you.
Yeah, hi guys, Wasil here. Firstly, I'm really excited to be part of the DevOps India Summit 2022. Again, it's a great initiative by Excellentro. As we all know, it's a great platform for folks to share insights and learn new technologies and tools, right? So yeah, looking forward for more sessions here. But I guess for now, we can get started with our topic. Like theme here is basically like networks have gone through an evolution over last decade or so, all right? From traditional WAN, Mpls, circuit-based to like SD-WAN, SASE-based complex solutions, right? And eventually, all of this is to make end-user experience faster, better. But is that really the case, right? Are the networks still observable? Right? That's an important question. And because like we should always look at network observability from application performance standpoint and digital experience perspective of end users. So we have to consider these things, right? When we look at our current state of our networks. And so we are going to focus more in upcoming slides on like what current state of our networks is and how we can make like networks more reliant, more observable, right? So let's take a look at our agenda. So we'll be discussing like evolution of WAN, right, and the associated technologies. We'll talk about like current state of networks. We'll talk about trends that we are seeing from the network observability standpoint, and like again impact on end user experience. And then finally we'll talk about like network observability and how we do that in Catchpoint, right? Let's go to the first topic. Evolution of WAN and solutions around it, right? So technically, I mean, any large network that spreads over the wide geographic area, that's the WAN, right? It connects multiple LANs to each other, right? And even internet, it's considered as a WAN, right? And on the WAN, like things have changed drastically from like early 90s to what we are seeing right now. Right? A traditional WAN architecture back in like 90s, early 2000s, right, where we effectively had like primary circuit and backup circuit, and I think backup circuit was like not used most of the time. So basically, all the traffic from your branch offices, it had to move to the headquarter or data center, right? Whether it's like internet-based traffic or application access, resource access-based traffic, it had to go directly to data center. And from there, data center, it used to make a decision, like if it has to kind of find something that's on-prem itself or go out to the internet and fetch it, right? So that's how traditional WAN networks used to work, right? And again, I mean, we would have seen latency accessing like even the on-prem stuff or even the applications out there. Those were accessible only over the internet, right? So MPLS was an important aspect of it. And I think like 80% of traffic, it used to flow between these branch offices and the main office or like data center, right? So it followed that hub and spoke setup, wherein like we had one hub, a data center, and then we had these spokes kind of communicating back and forth to that data center, right? So come to 2009, right? So early 90s, 2000, again, I mean, we had a solution. I mean, MPLS at that time, it was a golden standard, right? But again, costly, right? And with respect to like flexibility, less options for like enterprises before 2009. So when we moved to 2009, like network providers started talking or introduced SD-WAN to us, right? And what this SD-WAN is, I mean, if we talk about it, it's like a device, right? It's there. And now we had the MPLS, right? And we have like the broadband Ethernet. We have like 3G, 4G wireless cards, and like even multiple ISPs. They are connected all to same box, right? And then this box kind of helps make smart decisions, right? Or even like right now, we even have like cloud-based SD-WAN solutions. But I'm talking of like SD-WAN solution when it kind of appeared first time. Uh, so traffic from branch offices only destined for the data centers. It used to go through MPLS circuit. These SaaS applications or like even cloud like applications for that matter. So all of that, or even any websites out there on the internet, it used to directly go to internet, right? So it reduced that backhauling, right? It's not going like every connection is not going through data center here in this case. But again, with this SD-WAN, I mean, it's good. Like we have app aware routing. We kind of check the current state of our egress points, right? So if MPLS is good, if like this ISP1 is good, if ISP2 is good, if this 3G, 4G card is good, right? We kind of understand the egress points. And then based on the current state, like depending on packet loss, jitter, latency, you kind of make the decision smartly, right? That's the job of SD-WAN. And then, like coming to 2019, now with SD-WAN, that there was still one issue, right? So now users, all the connections, they were not going back to data center. So traditionally, data center used to have like a perimeter firewall, which used to do filtering for all the traffic. But now the traffic destined to internet or cloud, that's not being filtered, right, with the SD-WAN box. So we still needed to have something which kind of took care of the security aspect, and that is where the SASE comes into picture. So basically, we can say like SASE is SD-WAN, right, plus the carrier network, and plus secure internet gateway, right? So again, I mean, SASE, it isn't new. The idea behind it has been around for some time, right? And we've even seen like the vendors who started talking about SD-WAN, like they had always positioned the need for network security as a service, right? Such as secure web gateways. And they offered that alongside their SD-WAN solutions. And then eventually we now call it as like a SASE. And what basically led to this hybrid WAN from early 90s, early 2000s, and moving over to like SD-WAN, SASE-based solutions. Like firstly, cloud connectivity is there. Like things have uh, moved to cloud. Like it already happened some time back, right? And now we have more and more applications that are moving to cloud. So important thing, better cloud connectivity, right? Applications, since applications have moved to cloud, so there's a need for better connectivity to these clouds, and traditional WAN solutions fail here. Hence, SD-WAN like solution would surely help here because like SD-WAN based solutions, they like or SASE based solutions, they have like direct pairing with like these cloud platforms out there. So in case traffic is destined to these cloud platforms, it's pretty easy or like it's latency free there. Right. And the second aspect is the network flexibility, right? And SD-WAN, I mean, it can use multiple transports, giving it like tremendous amount of flexibility, enabling remote endpoints that can be configured for MPLS, broadband, Ethernet, 3G, 4G, cellular, and more, right? So that flexibility becomes really important. And even like demand for bandwidth, like bandwidth requirements have a kind of increased tenfold over time, right? I still remember like back when I started, like we were using dial-up connections and like 10 kbps. I think that's what it was, like 10 or 50 kbps. And it used to like seem like it's fast, right? But these days you are literally accessing applications that are heavy on data. There's a lot of data download that happens, or even like social media websites like Facebook, Instagram, Twitter. Like you're looking at data heavy websites, and that kind of caused like huge demand in network usage, right? So bandwidth requirement, like relying just on one like circuit, it's not scalable. So we have multiple options, and accordingly we can scale, right? And also there was issue even like on the MPLS provider side, right? Like turning on something, increasing something, it used to take time. Besides the MPLS cost itself. right? So these are the factors which kind of paved way for the hybrid WAN solutions eventually. And over here, you can see this pie chart, which talks about what happened to MPLS. This is, I think, from 2021, a survey wherein the questions were asked to certain enterprises, and then we see around 45%. There is reduced or no MPLS footprint, right? So yeah, I mean that's a trend that we are seeing right now with respect to WAN solutions. Now we talk about current state of our networks and the impact on user experience. So here are the current trends that we are seeing with respect to network observability. All right, so we see things on the network side that are pretty siloed in nature, right? Network teams, they focus wholly and solely on infrastructure and individual pieces out there and in the puzzle, and then hope that end user experience would be automatically better. But that's not the case, right? So pure network teams, they have tendency to focus solely on latency between the pieces of infrastructure, right, without knowing the impact on end user. And nowadays, we are talking about user experience a lot, right? We talk about digital experience monitoring. We talk about these things. It's like end user has really become an important part of this pyramid, right? Uh, so basically, most of the focus with respect to monitoring nowadays, it's on the end users, right? So it's important to understand end user experience on specific applications. It's not just code driven, right? And it also depends on the networks that are carrying the traffic for that application, right? And I guess, I think the businesses, they were never fully prepared for network evolution that we're seeing, right? It's still happening. We see outages related to network, right, with the big enterprises. If you remember 2019, Cloudflare outage, right, again, a BGP related issue. Facebook outage back in October 2021, Symptom DNS, but again, a BGP related issue. And multiple AWS outages or GCP outages out there. In 2021, specifically the AWS outages that happened at the end of 2021, right? So basically, the reality here is there are many organizations that try adapting to new solution, right? And that's just an afterthought, and just maybe another infrastructure fix. And it's the same patchwork approach that we have seen in the past, right? Issues are only addressed if something breaks, right? And ultimately costing businesses plenty of time and money, fixing legacy technology, right? And investing eventually in the future technology, right? And these days we are seeing new startups, even the enterprises who have been there, they are reliant more on the CDN networks out there, right? So if user is accessing an application, it's more often now I see whatever application, whatever website I'm accessing, it is kind of going through one of the CDN providers, right? You have Akamai, Cloudflare, Fastly, Edgecast, right, and so on. So these third-party services like CDN, DNS, they're spread across the internet, right? They're connected by networks that we don't own. So for traditional network performance management solution, traditional monitoring tools, it won't be easy to accurately measure them, right? So these are the trends that we are seeing from the network perspective. Again, I mean, now focus is kind of shifting over to end user experience, and network teams, they're kind of moving in the right direction now, right? But otherwise, I'm still kind of hearing when something goes wrong with the application, we start kind of saying it's the network, right? So that will eventually shift. And what exactly are the challenges that we are seeing these days, right? So firstly, I mean, since it's already happened, cloud, right? So applications have moved to cloud, and that these applications, they are literally, they're different. The way they are configured, how they are hosted. So basically, I mean, there's a loss in visibility from the cloud network perspective, right? So if it was an application, it was hosted on-prem, network teams, they had a complete network topology. They knew how exactly the things how exactly the things were placed, right? But now in cloud, that visibility is lost. Cloud platforms, they do expose some pieces of information, but again, most of it we have to kind of go through these details, right? And then we have, like, we talk of pre-pandemic, right, and post-pandemic. So pre-pandemic, it was all office networks, right? You wouldn't have like remote workers like that much trying to like do work from home and stuff. But like after, I hope it's like the post-pandemic, because with post-pandemic, organizations, they've kind of shifted to this hybrid model, right? So where an employees, they can come to office, they can work in office. So again, going through office networks, and then like work from home, that'll be like remote work and network, like home networks, right? So office networks, they are still becoming complex, right? You have multiple things. You still have servers. You have different devices, like multiple ISPs. You have SDWANs or any kind of solution in place, right? Still need to monitor that. That's still a challenge. And I think like the most challenging part with respect to like current network observability is the remote worker, right? So what happens is like users, they directly connect to over the internet to like anything in Azure, in GCP, AWS platforms, right? So they're coming from their home networks. And we know home networks are far more unstable and unpredictable than corporate networks, right? So ISPs, they're already experiencing an unprecedented set of new challenges in meeting increased demand for bandwidth and the subscriber base itself, right? And on the other hand, like enterprises have to keep up with the massive increase in like VPN usage, for example, right? So most network monitoring tools, they do give us great insight, right, from the device status level, like if device is up or down kind of a thing. But like we're completely blind to the end user experience at the home network, right? So that's still unpredictable. So these are the challenges like cloud. So we need to have like cloud-based monitoring, cloud observability for office networks, remote networks, or like home networks. We again need to have visibility from that network standpoint, right? And now let's come to this topic of network observability itself, right? So when we talk about observability, the definition, I'm just quoting it, it's basically an ability to infer internal states of a system based on external output, right? And like if I have to kind of talk about observability and monitoring, it would be monitoring tells us when something goes wrong, right? And observability enables you to understand why, right? And even we can say like observability, this whole concept, monitoring is kind of part of it, right? And from the network perspective, when we say network is observable, it means that the network or IT teams, they can easily understand the overall picture of how network impacts the services and experiences depending on it, right? So network observability metrics usually, they focus on the entire connection and the experience of end user rather than just looking at individual devices along the way, right? Um, so you can see, like, anything that happens these days with respect to application, network is the easiest thing to blame on, right? So we need to make sure, like, if our employees, customers, they can't reach the website's applications or complain about slow performance, right? We need to figure out, like, what's actually causing it without directly blaming the network. All right. And again, the important context for network observability is ensuring quality of user experiences, right? That's an important aspect. And like again, network observability as a whole, I think it has kind of gotten more importance in like recent years due to increasing complexity of networking architectures, right? So if you look in that earlier slide, like networks were pretty simple in nature, right? Like they were usually mapped to a specific location, such as like single data center, and configuration did not change consistently. But nowadays, if you see, things are changing like dynamically, right? So you have multiple CDNs that you are using right now. You have IPs that keep on changing. You have multi-cloud architecture. So network observability is really becoming important in today's world, right? So that's also the major goal of network observability, like to proactively surface network dependencies, right, or issues before they impact the end users. That's the whole point of user experience. And again, I mean, DevOps observability, it is kind of like complemented by network observability, right? So by giving teams total visibility into condition of network and effects on business, network observability kind of closes or bridges that gap, right? And now the important thing is like, are we actually observing networks from where it matters most? Right. So you can see like I have in this diagram, I have like the end user over here on the left, that's in the home. We have office users, right, trying to connect to these applications. They might be in cloud, or they can even be like on-prem, that's fine. So we need to have like observers, right? We will talking about network observability. So I need to have an observer that is in my network right now from where I'm kind of trying to access the internet, right? So if I'm in office, I want to have observer within my office premises, right? So that I can baseline, like, yeah, I mean, I have something on my laptop, which is kind of monitoring, proactively understanding if like I'm seeing slowness with certain applications or networks, right? And in Office, I can have like a separate observer, which is kind of going through these applications, these networks, and trying to find the baseline, right? And then we also have like the backbone networks out there, right? So you can see in this picture, I've highlighted like Catchpoint backbone nodes, right? Catchpoint backbone nodes, Catchpoint enterprise nodes, and Catchpoint endpoint agents, right? These enterprise nodes, they can be on-prem, right? Within the offices, they can be in like within your cloud infrastructure, within AWS, Azure, GCP, and then so on, right? That gives you that first mile perspective of where the applications actually are, right? And then, like when we talk of network observability here at Catchpoint, we kind of like do it in this way, right? Here's an example. So this, you see this Catchpoint. We have Catchpoint observers. The diagram on the left, wherein like it's a traditional setup, right? Wherein end user, right? End user, and then we have like offices, branches, like maybe a data center and home office, cafe kind of a thing, and then we have SD-WAN solution, and then we access applications that are on cloud, or like anywhere for that matter, right? Or in data centers. So we have three separate observers here, right? To observe the overall user experience, right? Uh, so we need to have like three separate vantage points to do that. So first one, as we mentioned, like endpoint. Endpoint is kind of like it sits on the laptop itself, right? So user accesses an application, user accesses like Office 365, user accesses Salesforce, and so on. And we get that end user perspective of performance on these different applications, right? And then it also gives me information about the network. So I'm doing that. So that part is covered. So the second part is, let's say if I'm in office, right? Or even at home, like we worked on these like projects in the past where like we are even kind of having a separate, like a mini PC, which we call, I mean, it can be a mini PC, it can be like a VM running Catchpoint agent on top of it, and you can place it like within your home, within your offices, like in these cloud platforms out there, right? That's the enterprise observer. And the third one is the public observer, right? Which is actually out there from the public. And in the previous slide, as you saw, like these nodes that I was highlighting, like node on Verizon ISP, Cogent, AT&T, like these major ISPs out there. So these are the observers coming from outside in, all right? Just as the end users would do. So I have like, I have the complete picture. I have the end user, right, actually accessing the application. I have like the office-based monitoring with the enterprise node, wherein I'm setting the baseline of what performance looks like from office. We have performance from home, and then we also have like external in kind of like performance understanding as well from these backbones, because like eventually end user customers, they are going to hit these backbone networks like while traversing through the internet, right? And on the right-hand side, you see this dashboard, right? It's kind of like talking about that SD-WAN piece that we have there in the diagram. So we have like overlay, right? It's an enterprise node which is just going through SD-WAN directly. So we see these numbers directly going through SD-WAN. And SD-WAN is taking the decisions, like if it has to go through like ISP-A versus ISP-B, right? And you can see that at the bottom, where we have like separate enterprise nodes kind of going through these individual egress points, right? So then it helps us to correlate, like, hey, SD-WAN, like this user was sent through ISP-A. This user was sent through this 3G, 4G card. Again, I mean, or if something has already been defined in the central policy, right? So we can actually correlate that with a better understanding here in this case. And like from the catch point standpoint, like we in our network observability, we cover DNS observability, CDN observability. We have network path observability, BGP, and the endpoint observability. And this is like a strategy that we kind of go through. Like first thing, we need to target and measure key infrastructure, right? That basically impacts the user experience, like DNS, right? That's critical component out there for the application delivery. Right, BGP ISP routing, if that is happening correctly. So if VPNs are performant enough, right, for cloud firewall, if they are working fine, if they are up and running all the time, right? So we can monitor all of these, like with the observers, which I was talking about in our previous slide, right? And then we also want to have a correlation of network performance with the application level data, right? So, I mean, it can be a business critical like application where user, let's say, opens the website, kind of goes through a transaction, and it's like 3 or 4 step transaction, right? So in Catchpoint, we kind of do that. We simulate the exact user journey, right, from the actual browsers. And then we kind of show you like the network performance as well for the same user experience, right? So if user was accessing this application, it went through the step 1, step 2, step 3, and what was the network health exactly at the same time. So it helps, right? I mean, we can't now straight away say that, hey, my page load time was higher and it's due to the network. So we have like we have the proof straight away and we can do the correlations correctly. And it's one of the popular use cases out there, right? So having like on-prem enterprise agent like directly within your infrastructure, doing first mile testing, and then having public backbone observer from Catchpoint doing the same application monitoring from outside in, right? And then like have a dashboard which kind of talks about this internal one where CDN is not involved, where DNS might not be DNS managed service, they might not cause any issue, and then the external view where all those components are in place. And I think it helped at least my clients reduce that mean time to detection, right? So if they see this, they see issue just internally, externally, they see issue externally and internally, they straight away figure out like, yeah, I mean, it's more of an issue towards the infrastructure, right? On the origin. And if they see issue externally, not internally, they kind of focus more on just those external components like DNS, CDN, and all, right? And again, it's important to have to track the SLAs, like you have SLAs with your CDNs, you have SLAs with your DNS service providers, right? You want to make sure they're doing that and they're delivering on those SLAs, right? And also like proactive detection of remote employee connectivity issues, right? So end user is at his or her home trying to access something. So we just want to have that agent which is sitting on the device, getting that device level telemetry, whether it's like Wi-Fi stats, whether it's like network health, whether it's the hardware, like the RAM or like the CPU utilization, and even like the core processes that are kind of impacting this end user experience, right? That's an important aspect. And when we talk about this DNS observability, right? So DNS, again, it's a critical component of application delivery chain, a necessary mechanism that makes global network communications work, right? Connecting services to internet. So it's important. So proactively pinpoint issues anywhere in the DNS hierarchy, right? That's really important. And like we need to understand, like for an end user, it might be simple. Like I try to type in a website name and I connect to an IP address, right? But under the hood, like maybe even for the first time, it's kind of going through multiple levels of hierarchy. It connects to root, then TLDs, authoritative name service, and then finally the A records or quad A records, whatever we are connecting to. So it's important to understand where exactly we are seeing slowness, we are seeing failures, right? And yeah, I mean, we know like most of it is kind of cached, right? So like IP addresses to DNS name that would be cached for some time. But let's say once that cache expires, TTL expires, user has to go through this again, right? So we want to have something in place to kind of get us that information by default. Latency, packet loss, round trip times, right? So all of that. And then we have network path observability, right? So roadblocks to in any network path, right? It could cause friction to digital experiences, right? So we need to identify those. So we do that using like trace routes. These trace routes can be performed on ICMP, TCP, UDP, and then with the help of these visualizations, we kind of understand how the traffic is flowing, right? Visualize like paths that the actual users are taking, right? And why is it taking long? So there were two paths available. The user is right now traversing through this path versus this path, and so on, right? So that might help us identify slowness in the path and see if there are alternative paths that might work better, right? And eventually have an alert mechanism. Like if I see X latency, I want to get alerted. And I also want to see what exactly is causing that. Like, is there a specific hop in between? Like a specific autonomous system that we are seeing latency on? Can you identify a specific router in that AS that is causing it, right? So that sort of information would be really helpful to understand network paths. Moving on, BGP, right? So BGP, again, it was never designed with focus on security, right? So it lacks any built-in packet authentication mechanism. So hence it's vulnerable to deliberate attacks and innocent misconfigurations, right? And these misconfigurations could be like route hijacking, like BGP route misconfigurations happen, route hijacking happens, route flapping, right? DDoS attacks happen. And again, these route hijacking or flapping, these could be like intentional or these could be like unintentional, right? So BGP, it gives you a view. So when you start monitoring it, like a simple thing, putting the prefix in, and we start collecting the BGP data from like our catch point collectors, route view collectors, and RIPE collectors, right? So we give you a holistic view of how exactly the internet looks like as pertaining to your specific prefix, right? So quickly identify misconfigurations that are causing routing issues, right? And even showing like short-lived routing flaps that aren't visible in traceroute. Again, traceroute is the GPS, whereas BGP is the actual map, right? And then the last piece in this network observability stack, that's the most important one, like the endpoint observability. And again, with limited visibility into how employee experience the technology they rely on, it's next to impossible to know what and how to improve, right? With a sustained move to hybrid work, these blind spots have soared from endpoint Wi-Fi, SASE VPN connectivity through internet maze to SaaS and cloud environments, right? So we kind of need to have a way where we are monitoring from where it matters the most, right? We need to have something, we need to have an observer which is there on the actual user device. So that is like basically achieved by our endpoint observability module. So it's like an agent which sits on these window Mac devices, kind of pull data from the browser, from the device itself, right? And we kind of get you like Wi-Fi strength. You have CPU, memory usage, core processes under the hood network. So how exactly is end user kind of traversing from point A to point B, right? So you can do like proactive testing, even from that front, without even telling your end users, without asking them to do anything, right? So schedule something, it runs off, and you have the constant monitoring going on, which eventually leads to like better observability overall from the network perspective. Yeah, I think that's it. So yeah, thank you. And again, I want to thank Excellentro for this opportunity. So there's more to come. Stay tuned for other sessions. Thanks a lot, guys.